Good morning, everyone. Welcome back to another exciting day of mathematics. Warm-up number 7 is on the screen. Once again, this is something that we did yesterday, and we're continuing on. See how you do with that. After that, make sure you get a Cornell note ready, like the one that is on the screen right there. Prayer model, and so on and so forth. Set that up, please. Copy and go. All right, do me a favor, share with your neighbors, see what you got. You should be done with 1 and 2 by now, if not already with all 4 of them. Go, share with your neighbor. All right, here we go. For the sake of time, let me help you out with this one. Whenever we have a negative here, and this one's not a negative, what did we ask you to do? Group it and put a what? A little plus sign in front of it. Yes? All right. How about this one? This turns into a positive. Okay. So with that said, check for any zero pairs. Any zero pairs, everyone? Yes, the negative 12 and the 12. So answer 27. 27. All right. Hands if you got that. All right. Not bad, not bad. Let's do the same for number 2. Group. Put a little plus sign right there. This one turns into a positive, and this one turns into a positive. Bless you. All right. Let's combine like terms. Start with x. We got 2 positive x's and 5 negatives. So can these 2 cancel 2 of the negatives? Yes, that leaves us with negative 3x. So far so good, yes? Next, we got negative 6y, and then we got 4y and 2y. So let's combine the positives first. What is 4 plus 2? And what happens to that? Woo-wee. Answer, negative 3x. Hands if you got that by yourself. Yes. Let's go. Go to number 3. That out. Number 3. Here we go. We got 46 equals 23 plus q. Line down the equal sign. We need to leave q by itself, so we need to subtract 23 from each side. Answer, 23 equals q. So far so good. Today we're going to hit this running, and we're going to little by little stack it up. We're going to end up with the variables on both sides of the equation. So just do me a favor, go like this really quick. Bear with me today. Bear with. Anyways. All right, let's go to number 4. Number 4 says x divided by 3 equals 8. Line down the equal sign. I need to leave x by itself. What is the 3 doing? It's dividing. What is the opposite of division? Multiplication. So we multiply times 3 both sides. Times 3. That becomes a 1. That leaves us with x. Negative 8 times 3. That's negative 24. All right? How we doing? All right, so today we're not going into Nearpod, just like I said, because we're going to be accelerating pretty quick. However, copy this code, please. Code for tonight. Oh, my bad. Agenda's next. Agenda, warm-up number 7. Today we're going to finish off, or at least get through most of the equations and inequalities. Equations and inequalities. And tonight's home play, only 8 problems. Only. Oh, and by the way, let me see. Right there where it says 8 problems only, I want you to do, oh, sorry. Do this, slash, sign, syllabi. Sign syllabi. All right, once again, warm-up number 7, equations and inequalities. That's what we're getting into today. Tonight's home play, 8 problems, and sign the syllabi. Now I'll show you how to get that. Copy this code. ZLD to M. ZLD to M. ZLD to M. So, this is what I want you to do. Now go to Nearpod. Test that code to make sure it opens up, please. Nearpod, test the code. All right, so once you log in with that code, the very first page that you're going to see is the syllabi. A PDF reader, yes. So tonight, make sure you sit down with your parentals, go through the entire syllabi, scroll all the way down, make sure they understand all the classroom rules, materials needed, school policies, and grading policies and all that. But I need you to go to the last page. Scroll down to the last page. Looks like this. Everybody see that? And it says for you to write your name and sign as well as them. This is what I want you to do. At home, pay attention to this part. At home, when you get to that part, you can either take a screenshot with your Chromebook or get your phone, take a screenshot, go to edit, then your parents can sign over it as well as you. Email that picture or save it, email it to yourself because you're going to turn it in tomorrow on Canvas. Explain to your neighbors, make sure they know what they're doing in regards to how to get that signed, please. All right, so do me a favor, log out of Nearpod, please. Once again, there's that code, ZLD2M, that's for tonight. That gives you access to the syllabi and to the home play. All right, next, look up. Last night's home play was, this, 8 problems, is that correct? Now check this out. Today, we're going to turn this in, but on Canvas. So open up your Chromebooks, go to Canvas. Go to my class. It should look something like this. Everybody there? All right, so let me show you around so you can see what you have in front of you. We have our math banner right there. It says, welcome to Mr. Q's Algebra 2 class. Let's go. Bam. Then here, I left a button so that whenever you're absent or you're elsewhere, that you're not here, you click on that. It sends you to my YouTube channel. Bam. I got skills like that. Now check this out. The way I upload every day, the last 2 videos that you see, the very last one is Algebra 1. The one before that is Statistics. That's how I'm going to be uploading. So whenever you're absent, go to the last one. That's your previous lesson. If you're absent more than once, then you go to the 3rd one down, which is this one. That's the previous lesson, and so on and so forth. Okay? Next, I left only 3 buttons here, Home, Grades, and Module. Click on Modules. Click on that. And there's your first assignment. 8 problems. Click on that. And now, take a picture and turn them in right there, please, on Canvas. Turn in your home play right there. And that's how we're going to be doing that on a daily. So make sure you're keeping up with that. Turn in your home play there. Give you guys some time. Go. This is tonight's home play. You have the code for that. Get a Cornell note right after you turn in your home play. Go. All right. So, y'all ready? So do me a favor, close your Chromebooks, your electronic devices. You don't need them. Like I said, today we're going to go pretty fast. So I gave you a heads up already. Okay, we already covered number sets. We went into expressions. Today we're going to hit equations running. So hopefully we get there. And I'm going to transition to inequalities. But like I said, I'm trying to go slowly but surely, little by little, just adding rigor as we go along. Here we go. I can solve one variable equations and inequalities. Our objective for today, I can solve one variable equations and inequalities. I can solve one variable equations and inequalities. Remind your neighbors, what is our main concept for today? What is our main concept for today? Main concept for today is what? Yes, one variable equations and inequalities. I'm still not getting to the two variables yet, but we're no longer in expressions. We're moving on. And yes, we're going to be solving those. Okay? So what are one variable equations? Writing utensils down, look up to the screen. Here goes a quick intro that I do every year just to clarify people's thoughts. Ready? Here it goes. Look up to the screen. So, in the past, in the medieval times, you guys, have you seen these kind of scales in those movies from back in the day? So the way those work is that whatever weight somebody was trying to buy, let's say, some apples, that you place them on one side, you add weights to the other side that reflected the same amount that you're putting onto one side. For example, if I place 8 pounds on this side, what do I need to place on this side so it can be balanced? 8 pounds. Then that's how it balances out. But what if this side had more weight? 11 pounds. How many more did I need to add to this side? 3 more, and that's how it balances out. Well, guess what? That's where we get equations and inequalities. Watch. Look up to the screen. Here's a table. Here's the bar of the balance scale. What symbol does that make? An equal sign. You're like, what? Yes. Now check this out. I have 8 over here. Oh, sorry. 8 over here. 11 over here. What was the original bar? It was right here. Is that correct? And it dropped like this. What symbol does that make? An inequality symbol that says 8 is less than 11. You're like, and so on and so forth. That's where we get the balance scale. So that's why in this next exercise, when I'm talking about equations, I'm going to draw a line down to simulate the scale. Line down to simulate the scale. So like that we can keep it balanced along the way. Everybody with me? So with that said, on your Fair model, write this down. One variable equations and inequalities. What are one variable equations and inequalities? Definition. 2 expressions that are equal or not equal to each other that contain one variable. Write that down. 2 expressions equal or not equal to each other that contain one variable. And right there, as you're writing the definition, where you get to equal, you draw the equal sign. Not equal, you draw this. Those are the symbols for not equal. Two expressions equal or not equal to each other that contain one variable. Freedom. Just put it on top of the table, and tomorrow I'm going to bring some other tape that's stronger. Thank you. All right, examples. Here we go. X plus 2 equals 25. 3x plus 2 greater than or equal to 25. Now, copy those. I'll wait for you, and then I'll elaborate. All right, here we go. According to the definition, each one of these are 2 expressions equal or not equal to each other. So let me go back just to this one. Look up, writing utensils down. I'm going to focus on this one only. According to the definition, we have two expressions. So let me ask you this. If I was to get this out of the way, is x plus 2 an expression? Yeah, by itself, it's an expression. How about if I was to move this over and scribble over this? Is 25 an expression? Yes, it's expressing an amount. So, do we have an expression equal to another expression? Yes. So look at this one. Is 3x plus 2 an expression? Yes. Is 25 an expression? Yes. This is an inequality sign, which makes it not equal to one another. Even though it has a little equal sign at the end, we'll talk about that as we move along. Copy these next two. 12 equals y minus 8, and 12 less than 4y minus 8. And once again, we don't need our electronic devices. Put those away, please. Copy this next one as well. 2a equals to 14. 2a plus 8 less than or equal to 14. And one last one. Negative 3 equals m over 4. And negative 3 greater than m over 4 minus 6. All of those are examples of one variable equations and inequalities. Now notice at the end on the definition it says contains one variable. This one only has x, x, y, y, a, m, m. Only one variable. You good? All right, so now that we know what they look like, look at the none example. Don't copy it yet. Tell your neighbor why the first one is not a one variable equation and why the second one is not a one variable equation. Talk it over to your neighbor. Why are those not one variable equations? All right, good conversations. Let's see, this one. Why is this one not a one variable equation, Enrique? Okay, so now I'm using this as an example because I gave you guys time to talk to each other, right? That gives you time to ask questions to your neighbor to make sure you know what to answer when I call on you. So if I was to ask Gio, why is this one not a one variable equation? It's got a subtraction, it's got an addition. Close, close. Everybody look up, look at all these. At that one. The equal sign. This is not an equation or an inequality. So, tell your neighbor, what do we call this if it doesn't have an equal sign or an inequality sign? What is that called? An expression. That is correct. We just finished expressions. That is correct. So, with that said, tell your neighbor why this one is not a one variable equation. Tell your neighbor why that one's not. Gio's going to pass it to someone. Why is this one not a one variable equation? All right, Gio, pass someone. Mario, why is this one not a one variable equation? It has two different variables. That is correct, x and y. Now question, bonus question for Mario. Don't tell him, please. If these are called one variable equations, what would we call that one? Ooh. Close. The expression is this one that doesn't have an equal sign. Close. These are one variable equations and inequalities. What would we call this one? Two variable equations. Let's go. That is correct. Get that out. All right. Write this down. Copy those, and we're going to add some hashtags to that. What makes a one variable equation one variable? Well, first of all, hashtag one variable. Hashtag one variable. And what makes them equations? Well, hashtag equal signs and those kind of signs. That's what makes them what they are. All right? So, with that said, now that you have the notes, this is the process that we're going to use today. Ready? Don't copy this. We have simplify each side of the equation, because there are expressions each side, right? Isolate the variable, that means leave the variable by itself on one of the sides. Plot your solution on the real number line, and at the end, check your solution. Simple steps are these. These are the steps that I have people remember the process. Simplify, isolate, plot, and check. Simplify, isolate, plot, and check. Simplify each side, isolate the variable, plot, and check. So, with that said, y'all ready? All right, on your notes, copy these, please. Example Q. This is A, B, C, D. All right? So, follow along. I'm going to zoom in to A. We're going to do that one together with the entire process. Here we go. Solve. Line down the equal sign. Circle the variable. We need to leave x by itself. Can we simplify anything on that side? No, we can't combine this side, no. So that means we need to get rid of the positive 2. How do we do that? Inverse operation. So what do we do? Minus 2 to both sides. Why do we do that to both sides? To keep it what, Jesus? Balanced. That is correct. So therefore, cancel this. X equals 23 microjoules. All right. Next. Ooh, nice hezzy. All right. Let's go to the number line. Write this down. Copy the number line. Start at 0. What is the answer for this one? X equals what? 23. So you go 1, 23, and plot your points. That's what I want you to do. So we check to see if we can simplify. We isolated the variable. Simplify, isolate, plot. And now we can check. Here we go. We take the original equation. We're going to check. We do x plus 2 equals 25. But instead of x, what do I write there? 23 plus 2 equals 25. Is 25 equals to 25? Yes. All right. Let me zoom out. Do that one for for letter B, this one. Do that same process for letter B. Go. All right, here it goes. For the sake of time, line down the equal sign. Where's my variable? Over here. Can I simplify this anymore? No. That side, no. Circle your variable. We need to get rid of the negative 8. How do I do that? What is the opposite? Plus 8. Plus 8. We need to do the same thing to both sides to keep it balanced. We're left with 20 equals y. Hands if you got that. All right. Plot our point. Here's the number line. 0, 1, dot, 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 20. Plot your point. There it is. Next, let's check. You write your equation again. 12 equals y minus 8. But instead of y, what do we write, everyone? 20. So then we got 12 equals 20 minus 8. What is 20 minus 8? 12. Is 12 equal to 12? Yes. How are we doing? Is it coming back? Now, mind you, these are the easiest equations ever because this is taking you back to 4th and 5th grade. These are known as one-step equations. Why do they call one step? Because it only takes one step to solve. Now, this one we did subtraction. This one we did addition. Do this one together. Negative 2a equals 14. Line down the equal sign. Circle your variable. When you have a number on the left side of the variable, it's multiplication. So how do we cancel the negative 2 that's multiplying? What is the opposite? Divide by negative 2. Because it's multiplying, the opposite of multiplication is division. Whatever we do to one side, we do to the other side. Negative 2 divided by 2 is a. This is 14 divided by negative 2. It's negative 7. For the sake of time, don't plot it. Don't check it. Let's go to letter D. Letter D. Negative 3 equals m divided by 4. Line down the equal sign. Can we simplify either side? No. Circle your variable. What is the 4 doing to m? What operation? Division. What is the opposite of division? Multiplication. So we multiply times 4 both sides. We're left with m. 4 times negative 3 is negative 12, and so on and so forth. From 1 to 5, how are you doing with those? We good, right? Okay, let's crank it up a little bit, yes? Here we go. Woo-wee. Copy these, please. Example, super Q. Example, super Q. This is A, and this is B. Copy them first, then we'll do them together. Here we go. I'm going to zoom into this one. Here it goes. Example, super Q, and then we got letter A. Line down your equal sign. Line down. There it is. Now check this out. Can we simplify this side anymore? No. This side anymore? No. So circle your variable. What is the negative 5 doing to x if it's on the left side? It's multiplication. So put a big dot right there so you know that it's multiplying. However, we have a 12 next to it. What is that doing? Addition. So whenever you have two operations like that, always start with addition and subtraction and do the opposite. So here we go. We need to get rid of the 12. So if it's addition, we need to do what? Subtract 12, subtract 12. This cancels. Bring down the negative 5x equals 2. 37 minus 12, that's 25. Circle your variable one more time. And remind yourself, what is the negative 5 doing there? What was it doing? So what is the opposite of multiplication? Divide by negative 5, divide by negative 5. We're left with x equals 25 divided by negative 5. That's a negative 5. We're getting there, yes? All right, we're not going to check. We're not going to graph for right now. I just wanted to show you the entire process on the other ones. I want you to do number or letter B by yourself. Do that one by yourself. Let's see. I'll get you started, and then you finish it off. Let me zoom out. Line down the equal sign. Circle your variable. So we have the 9. What is the 9 doing? So put a little division sign so you remember that that's the operation that's happening there. What else do we have? Subtraction. All right. So you know where to start and then go from there. Go. Finish it off, please. All right, here we go. For the sake of time, where do we start? With division or subtraction? Subtraction, right? So what is the opposite? Add 12. Add 12. That is correct. This cancels. We're left with 12. Take away 7. That leaves us with 5. M divided by 9. And again, circle the variable. What operation was it? Division. So what is the opposite of division? Multiply times 9. Multiply times 9 both sides. This becomes a 1. 1 times m is m equals to 45. Are we doing? Yes? From 1 to 5, I'll come through you with two-step equations. Yeah, we got this, right? 4, 4.5. All right. Shall we crank it up a little bit? Woo-wee. Go, Caesar! Yeah, we got this. Copy these multi-step equations. You're like, Mr. Q, that's in O snap. O snap is right. Example MJQ. We got A and we got B. Copy that, please. Writing utensils down, look up to the screen. All right. Look at example A. Pay attention, please. I want to clarify doubts in your noodle. Now, I know most of you love fractions. I get it. But some of us don't. So, first thing I'm going to do is get rid of all the fractions. How do we do that, Mr. Q? Pay attention. We look at the denominators and find a common denominator. Look at 3, 4, and 12. Tell your neighbor what would be a common denominator for all three of them. Correct answer is 12. That is correct. So that means I'm going to multiply the entire equation times 12, but I'm going to write it as 12 over 1. Write that down, please. So we multiply times the common denominator. What are we multiplying times? The common denominator. Here we go. What is 12 times 2? 24 over, what is 1 times 3? 3, and then we write the variable r, plus 12 times 3, 36, and what is 1 times 4? 4. Next, 12 times 7, that is 84, over 1 times 12 is 12. And check this out. Look at the next step. The next step gets rid of all the fractions. What is 24 divided by 3? 8r. 36 divided by 4 is 9. And what is 84 divided by 12? 7. Do you know how to solve this kind of equation? Yes, finish it off, please. All right, let's see. From there, we said, we know how to do these, Mr. Q. Line down the equal sign. Circle your variable. What is the 8 doing right here, everyone? It's multiplying, so there's my big dot, so I know it's multiplying. What else is happening here? Addition. So what is the opposite of addition? Subtract 9, subtract 9. That is correct. Bring down the 8r equals 2, negative 9 and positive 7. 7 of these, cancel 7 of those. We're left to negative 2. Let's continue. Circle your r. What is the 8 doing again? Multiplying. What is the inverse? Divide by 8. We do that to both sides. So therefore, we're left with r equals 2. Negative 2 over 1, negative 2 over 8. Simplify that, that's negative 1/4. If you got decimals, then it's negative 0.25. That's fine. Therefore, I want you to do B by yourself. B by yourself. I'll leave this one right there so you can see the process. Do B by yourself. 2/5 x plus 3 over 10 equals 1 over 20. Go. And for that part B, look up. Do me a favor. Change the equation into this symbol. Less than. I just want you to get away that it's different. It's not different. The process is the same. You just write the symbol at the end the same as you started with for right now. All right, let's see. Check with the neighbor, see where they're at. They should be almost done. I'm going to draw a line down the inequality symbol. Mr. Q, I need to get rid of the fractions. Okay, so we multiply times, what was our common denominator? 20. Hands if you wrote 20. That is correct. So we write 20 over 1. Here we go. This is 40 over 5x plus 60 over 10 less than 20 over 20. When you simplified, you ended up with 8x plus 6 less than 1. Hands if you got up to right there. Next, let's see, circle your variable. There's multiplication and addition. Where do I start, everyone? Subtract 6, subtract 6. We're left with 8x less than negative 5. And last but not least, we need to leave x by itself. Divide by 8. Divide by 8. X is less than negative 5/8. This is what? This is too easy. Not too easy, it's one word. Too easy. That's my word. All right? We'll stop right there because the bell's going to ring in about 30 seconds. So you have the code, get the syllabus signed, and also work on the 8 problems that I left you for home play from these. It's going to be practice of that. And we're going to go over some of them tomorrow as you walk in, but also I'm going to have you turn them in. So stop right there.